Hello, welcome to my channel. Look what I just got. I don't know how to say this. FNIRSI, FNIRSI, I'm not sure. DSO-TC3. Now, I was humming and ahhing about ordering its predecessor, the TC2, which on the face of it looks very similar. But this one has a function generator as well. I got the TC1. I don't know if you've ever seen the TC1. The TC1's kind of like bottom basement price component tester, and that's pretty much all it does. And then I saw the TC2 come out, which has got a built-in oscilloscope, and I thought, would I really use it? And then the TC3 came out with a built-in function generator as well. I thought, oh, and double the bandwidth for the TC2. The TC2, I think, no, more than double the bandwidth. I think the TC2 had a bandwidth of 200 kilohertz, where this one is 500 kilohertz. So I thought let's give it a go. Let's have a look. I bought this off of AliExpress. And you'll know a number of little vendors selling these things now. They seem to be very widely available. And it comes with just the TC3 by itself, or I bought the upgraded pack, which comes with a ×10 probe. That's kind of like your standard stuff, with an adapter as well, which can connect into the TC3 coaxial connectors. Let's open it up. Oh, I just noted the specs on the back. It says 10 mega samples a second, real-time sampling, 5 kilohertz bandwidth, 4 trigger, single, normal, and auto. Measures signals up to plus and minus 400 volts. I think, that's only with the ×10 probe, but we'll have a look later. Equipped with a 1-button auto simple adjustment that can display the measured waveform. Oh, that'd be good. Function generator, 6 kinds of signal waveform: sine, pulse, triangle, ramp, DC. That's what sold it for me. And up to 100 kilohertz. Well, I guess that 100 kilohertz will depend upon the wave type. We'll have a look at that. Other functions: continuity test, 0 to 40 volt input measurement. You see, this is what is different from measure voltage, so like 400 volts, so that's ×10 this. I guess we'll find out a bit later. PWM output, well, this is good for testing all sorts of things, such as laser diodes and some motor controllers. 0 to 32 volt Zener diode measurement, that's pretty impressive. DS1820 temperature sensor measurement. DH11 temperature humidity sensor measurement. If you don't know what these are, guys, these are modules which typically makers and Arduino users will use to get temperature and humidity measurement into their projects. Oh, and of course the transistor tester or component tester. All right, let's open it up. Well, it's well packed, I gotta say that. Look at the effort they put into the packing. Now, what we got in here? Okay, so we got a couple of crop clip ended test probes for a coaxial connector, USB-C charging cable, and 3 test probes. I guess this is where you'll put this into the zero force insertion socket, and then you can test components externally. Okay. It's quite a thick manual, you know. Look at that. Probably in 14 gazillion languages. That's probably why it's so thick. A page for each language. Oh. Well, you know what? This looks actually professionally written and presented. I'm quite impressed. Okay, we'll come back to that if we need to, but so far so good. Oh, warning. Probably discharge your capacitors. That's probably what it says. Let's have a look. Before using the device to measure the capacitor, please discharge. Yep, saw that one coming. Simultaneous use of the device while charging is prohibited. Prohibited? Oh, a bit strong. Okay. Please don't mix KAA test holes with other 1, 2, 3 test holes. It will burn the device. Now that might be where it's producing a high voltage on the KAA connections to generate that 30 volt, 32 volt Zener diode test. Please don't lock to measure the voltage. No idea what that means. Please do not measure the voltage value beyond the range 40 volts. It just said on the back of the packet up to 400. The device has no reverse connection protection function. Please do not reverse the measurement when using it. Okay. Digital oscilloscope function. When using the oscilloscope, pay attention to the selection of the gear. The gear of the oscilloscope should be consistent with the probe. Okay. Please don't measure voltage beyond the voltage. Okay. Right. I'll tell you what, the packing is really good. Ta-da! It looks really well made. It feels like a quality product. The plastics feel good. Not sure about these sockets. 0 to 40 volts, I guess that's for the voltage test. DSS must be the function generator output, and DSO must be the scope input. Oh, and at the bottom we've got the USB-C charging port. It's really good size actually. Nice to carry around or put in your bag. Oh, and it's got a little kickstand. That's cool. See what the display is like. Nice graphical interface. Okay, so you've got the oscilloscope, function generator, tools, M tester, I guess that's the component tester. You know, this is branded in many different places as being the FNIRSI transistor tester, but it's a lot more than that. I don't know why they put transistor tester. It can test a lot more than transistors, as we'll find out later. A little hole there. I don't know. That's why I don't you can see that. Oh, that's maybe a reset button or something. Okay, let's try it out. Have a look at the specifications. I'm not going to go through all of them. I'm sure you can just pause the video and read them if you wish. The key things are real-time sample rate, 10 megasamples a second. Analog bandwidth 500 kilohertz. We'll test that out later. Input resistance 1 mega ohm. Coupling AC/DC. Test voltage range 400 volts. That's with a times 10 probe, by the way. Vertical sensitivity 10 millivolts, 10 volts. Time base 1 microsecond. That's pretty. Well, okay, you've only got a bandwidth of 500 kilohertz. And up to 10 seconds, trigger mode, auto, normal, single, rising edge, falling edge, okay, waveform freeze, automatic measurement. Then the component tester. One of the interesting things about this is that it goes up to 32 volts, and I bet it's only got like a 3.7 volt battery inside, so it must use some sort of inverter. But take care, if you put a sensitive device in the KAA test area, which are these 3 pins down here, you're going to get 32 volts across it. So use with care. That's just for Zener diodes or Zener diodes, depending on where you're from. Parameters down to 25 puffs. Up to 100 millifarads. Resistor measurement 0.01 ohms to 50 mega ohms. Well, that's pretty good. Inductor 10 microhenries to 1000 millihenries. Battery volt, okay, you can measure batteries as well. Voltage input 0 to 40 volts. Okay, not really interested in the rest. Function generator, and one of the reasons I bought it. Sine wave 1 to 10 kilohertz, 0 to 3.3 volts, 50% duty cycle. Square wave 1 to 100 kilohertz, 3.3 volts. I think that's fixed, by the way. I don't think you can change that on a square wave. 50% duty cycle. Pulse wave, again 1 to 100 kilohertz, 3.3 volts. And you can change the duty cycle between 1 and 100%. That's great for testing servos and laser diodes and stuff. Triangle wave, 1 to 10 kilohertz. Okay. And ramp, okay, the ramp you can change the duty cycle, so I guess that's changing the shape of the ramp. And then DC reference voltage, 0 to 3.3 volts. Okay. There you have it. Well, the first thing I have to try is to see how good it is at testing parts. I'm not expecting any surprises here. It's probably a similar code that they use in the TC1 and TC2, and well, it does what it does. Let's try it with a diode, LED first. Flashes the LED, that's nice. Forward voltage 1.97 volts. Reverse current 86 nanoamps. That's interesting. Must be testing leakage in the reverse direction. That's interesting. Nice display. Let's try it with a blue diode. No. Forward voltage 2.78. Yeah, it's higher for a blue diode. Reverse current 91 nanoamps. Gosh, that's a small current. Let's try with a transistor. What is this? Oh, it's a 2N222. No, 2222. Okay. Okay, looks reasonable. NPN transistor, HFE 170. Okay, Well, no surprises there. Yeah, it works as a component tester. Oh, go on, I'll just try one more. I'm going to try a capacitor. Let's try... I got a horrible cheap electrolytic capacitor, 100 UF. Try that. Taking some time. Pretty close, 94.8, V loss 0.1%. Resistance, effective series resistance, 0.2 of an ohm. Cool. Okay, let's test the oscilloscope. So I'm going to get my probe and I'm going to put my adapter on it. Let's put it DSO. Actually, that's not as wobbly as I thought. I watched Dave's video on EV blog when he reviewed the TC2, and he showed a lot of concern about how wibbly wobbly these things are, but they're not that bad. In the long run, maybe I might even change these to SMA connectors, you know, the ones where they've got the threaded insert thingy, the threaded attachment, thank you, which might make it a lot stronger, more durable. Well, let's see. Right, oscilloscope. Ooh. Right, first things first, I need to calibrate my probe times 10. Okay, first issue. There's no tab on here, tag with a square wave output. Most scopes have like a 1 kilohertz square wave output. You can use to put your probe on and then turn the little, oh, wait a minute. Wait a minute. How do I calibrate this thing? Come on. Oh, it's on here. What am I thinking? All right. Yeah, so normally there's a little square wave output and you twiddle this compensation capacitor to get a nice square wave. So you know your probe is calibrated, but no square wave output. What to do? Tell you what we could do. We could try and use that function generator, but I bet I can't use it at the same time as I'm using the scope. So, let's give it a go. So back, function generator, okay, square wave, 1 kilohertz, fantastic. Okay, is it on now? Guess it must be. I bet that's not still running. I'll be amazed if it is. 10 millivolt. How do I navigate this thing? Okay, 10 millivolt. Let's make it 1 volt per division. Okay, let's see. Is that the square wave output? Is it still running? That'd be amazing if it was. Time base, how do I change time base? Okay. Well, what do you know? 1 kilo, it works. You can use the function generator at the same time as you can use the scope. Well, I'm already impressed. Now, where's my little screwdriver? Okay, let's see if this works. Whoa, Bob's your uncle. Look at that. I'm impressed. This thing cost me about $60. That was Singapore dollars, by the way. So you need to do your necessary conversion. But tell you what, I'm already impressed. Okay, so I'm now calibrated. Well, the first thing I want to do is test this bandwidth. It says 500 kilohertz. Is it really 500 kilohertz? Let's find out. So happens I've got a function generator that will allow me to test this. Let's have a go. Okay, so I'm going to do a bandwidth test, and I connect it up to arbitrary waveform generator, and I've got the output amplitude set to 10 volts and the output frequency currently 30 kilohertz. And the first thing I notice is the VPP is a bit down, say 9.5 instead of 10. And the frequency is kind of jumping a bit. It's kind of just about there, kind of 30 kilohertz. But it seems a bit unsteady on its triggering. I don't know, I'll play around with that later maybe. So I'm going to take it up now until it's 0.707 in amplitude, which should indicate that it's reached its bandwidth limit. So I'm going to go up in frequency. Oh, that's amplitude. Okay, let's try again. Silly me. Okay, let's go up in frequency. 100. 200. It's a bit alarming how much it's juddering there. The frequencies all over the place. Let's try changing the time base. Okay, sorry, that's 290. But you can see the frequency is jumping around quite a lot. Okay, that's supposed to be 300. It's sometimes measuring 302, 28, but it's still showing 8.9 volts. Remember, we got to get to 0.707, so 7.07. Okay, so I'm now at 500 according to my function generator, and it's 8 volts, so it's already exceeding 500. I go up. And you got 7.07. Wow, here we are. So according to my function generator, it's 650 kilohertz, even exceeding the quoted 500 kilohertz bandwidth. So again, another win. Bit worried about why the triggering is so jumpy and the frequency measurements so erratic. I'm going to play with that, see if I can improve it. Okay, I've tried messing around with the trigger. I don't know if you can see on the right hand side there, and there's an arrow which is blue. The things which are in blue are the items which are selected. You go left and right to select different things. So I'm going across to the trigger point arrow on the side. It's turned blue and I can move it up and down, but I can't seem to stabilize the signal. I'm going to go across to trigger type. You see it's normal. I change it to single. Of course it freezes. Or I can change it to auto, and if I press this button it causes the auto function to execute, which is pretty cool. Nice and easy to resolve signals, so you'd have to go through all the different menus to set things up. Okay, well still I'm pleased with this. That it's got better bandwidth than 500. I'm going to crank it up a bit more. Let's see how far I can take it and it still be relatively useful. Okay, now it's at peak voltage of just under 5 volts, and we are at 960 kilohertz, but you can see the frequency measurements all over the place. But if you didn't care about that, you just want to use it to trace signals or whatever, or fault finding, does it really matter? In principle, you can use this way above 500 kilohertz. It's only if you want to measure the amplitude of a signal accurately it's really going to cause you a problem. The time base is a bit restricted. The lowest time base you can go is 1 microsecond division. Let's see how far I can take it. I'm going to make it a bit more sensitive by reducing the voltage per division. Okay, I'm now at 1 volt. Let's keep going up in frequency. Okay, I'm now at 2 megahertz. Got some aliasing going on there. Increase the sensitivity. Yeah. Oh, that's horrible. Okay, but this is 4 times its rated bandwidth. The frequency measurement is shot. The voltage measurement is shot. Yeah, it's not much use at 2 megahertz, that's for sure. But going up to maybe 700, 800 kilohertz for fault finding. You could work on AM radios and things with this. Check the IF stages and things. I'm going to take it up to 800 kilohertz. And reduce the sensitivity. That's all right, let's put it in auto mode. Cool. Okay, this is 800 kilohertz. You see, that's pretty good for fault finding, that sort of thing. You just want to know if there's a signal there. So you can freeze a waveform just by holding down the run button, and it captures it. But I can't see any way of expanding the waveform. We're utilizing the memory that it's got. Try changing the time base. No. Well, what did you expect? Now going to try this little scope with a square wave. To faithfully reproduce a square wave, you'd need good bandwidth to resolve the harmonics which are contained in square waves. If you don't, then you lose the higher frequency harmonics in there and you get a distorted shape. So I currently got a 10 kilohertz square wave. According to my function generator, the amplitude is 10 volts peak to peak, which is what we're seeing here, more or less, 9.6. Not that accurate, but it is only a cheapy scope. All right, I'm going to increase the frequency now, 20 kilohertz. So let's just take it up to 100. I'm going to use auto function because I'm lazy to get the new waveform. You see how useful that is? Now look at that rounding on that square wave. It's starting to not look so hot anymore. And that's at 100 kilohertz. Let's keep going up. Let's go to 200, which is the bandwidth for the DC2, incidentally. Okay. Auto. I like this auto feature. You see it's now looking a bit more worse for wear, looking a bit rounded. Let's take it up to the scope's bandwidth, which I know it's going to struggle with because the harmonics in the square wave would be much higher than 400. Sorry, 500. Okay. Auto. So it's now our 500 kilohertz square wave is now being shown as a sine wave, pretty much. So that's where bandwidth is important. Right, I'm not going to try testing it more than that. So for complex waveforms, square waves, you're probably, this scope is probably useful for less than 100 kilohertz. If you're signal tracing, sine wave based stuff like AM radios and things like that, probably good up to 600 if you're not too worried about voltage accuracy. And you could even use it up to 800 kilohertz. Arduino projects is probably great for as well. If you're just looking at the square wave or pulse width modulation outputs of an Arduino, probably great for that as well. Audio amplifier, fault diagnosis, frequency range is perfectly good for that. I don't think I'm going to show you too much more about this scope. I think you can see it's got the basic functions here. We can highlight here the offset voltage, so you can move where 0 is, the reference. You've then got the trigger type, auto, normal, or single sweep. You've got the sensitivity, voltage per division, goes up to 100 volts per division. That's because we've got a time 10 probe selected. It goes down to 100 millivolts per division. Again, that would be, I imagine that'd be 10 millivolts if you're using a times 1 probe. Times 1 times 10 probe. time base, or from 1 microsecond to how far we can go. 10 seconds. That's pretty cool. Got coupling, AC/DC, and you can pause holding down the run button. You can get rid of the display showing you the various characteristics of your waveform by holding it down. Put it back on. Okay, I mean that's pretty much it for the scope. Okay, to go through the rest of the items in the Toolbox menu, let's select Tools. Okay, so you got this thing called Tongduan, and I found out what that actually means is continuity test. And the way that you use it is that you use the component tester input. So I'm just going to select 1 and 2. And then I don't know what the threshold is, but you can hear that when it gets below a certain resistance, go off. It's quite quick. One of the important things about a good continuity tester is it's quick. You can see that's very responsive, not bad. Would you use this for a component tester rather than a multimeter? I doubt it. I cannot see you buying one of these before you have a basic multimeter. I would have thought everybody that would be interested in having one of these would already have one already, a multimeter already, so kind of redundant. I feel the same about this voltage test that we just used. And also do note that, remember in the warnings leaflet, or kind of the addendum which was thrown in next to the manual, it said there as one of the warnings it doesn't have reverse voltage polarity. Now that doesn't make sense that applies to the oscilloscope input because it's an AC input. But I'm presuming this is a DC input and it uses that connection on the top left there where it says in 0 to 40 volts. You know, it could be quite easy to connect it reverse polarity and then damage it. Again, I don't know why you would use this rather than use your multimeter, which I assume you'd already have one of those. So I think the first two functions, although interesting, I don't think I would ever use them on this. The next one, this DS-18B20, I think is a temperature sensor module, which is used to provide temperature input to like your Raspberry Pi, Arduino projects. Not really sure why you'd use this, maybe to test them, but kind of a rare scenario, I think. In a similar way, I think the DHT11 is a temperature and humidity module. Same comment applies. IR decode, infrared decode. So as I understand it, this is about testing remote controls, right? So I got remote control here. I'm just going to point it at the device and press OK, and you can see there it displays a user code and data code. Again, quite a rare scenario, I think, where you would use this function. And then we've got calibrate, which looks like it's spelled incorrectly, but never mind. What this is used for, just with all the other component testers in the range, the TC1, TC2, and clones, this is used to in some way calibrate the component tester before you use it. So the idea is, I'm not going to demonstrate this now. There's plenty of other videos on the predecessors, TC1, TC2, show how to use this. You put in the 3 extension cables such as this. I've only got 2 here. We get the 3 of them. You connect them all together and you press calibrate, and it does something. Oh, camera's shaking there. Sorry. It does something to calibrate the component tester. Well, that's it for tools. Right, the next thing to try is the function generator. Okay, so we've got sine, square, pulse, triangle, ramp, and DC. Okay, so all right, we can change the frequency. This goes up to 10,000. You can hold it down to increase or decrease, or you can select the digits to increment or decrement. That's pretty cool. That's pretty cool. Not sure how I get down to set the amplitude. Okay. I'm having problems here navigating this. Okay. And it goes up to 3.3 volts. Okay, you can increment it, decrement it in steps of 100 millivolts. Okay, very cool. I don't have a separate oscilloscope here. I'm actually traveling. I'm in a hotel at the moment, so I'm pretty limited. And how do I get to sine wave? Okay, in again. Okay, got square wave. Just frequent. Oh no, you can't change the amplitude. Okay. Tell you what, the menu on this function generator could be improved. Kind of a Friday afternoon job, I think. Come on, FNIRSI, this is a fantastic little unit. I think we could have made the menu a bit more intuitive. Okay, I'll get the hang of it. I will. Pulse generator. Okay, it's got duty cycle. That's cool. I don't know what the output voltage is, since you can't change the amplitude. I'll try and find that. Triangle. Okay. Ramp. Ramp with duty cycle. Okay. Okay, that's pretty cool. That's pretty cool. If only I knew how to get out of this menu. And then DC. Okay. So DC reference from 0 to 3.3 volts. Anyone can guess what the operating voltage of the electronics is? I bet it's 3.3 volts. Okay, cool. I think I'm done with this. I think it's it's a cool little device. I paid 60 Singapore dollars for it, maybe a bit more, 65, which I guess is about 42 pounds. I guess it's probably about $55, something like that, US. So all in all, for a little device to take around with you for fault finding, or even if you just wanted to use it as a signal generator for fault finding audio equipment and stuff. And don't forget, of course, the component tester. It is pretty good. Yeah, definitely recommend this. Thanks for watching. If you found it useful, please give me a thumbs up and subscribe. Love to know your comments. If you'd like me to test anything else on this, let me know. I may even be tempted to do a little teardown, but I cannot see any screws. I'm gonna have to pry it open, I think. Kind of a shame, since it's a nice case. But maybe if enough of you ask for it, I might do. Thank you very much. See you next time. Bye-bye.